Okay, here's some data I collected from an experiment. This is fake data, but let's pretend I dropped a ball from these heights and I measured how long it took to hit the ground. If you study physics, you know that's not going to be linear, but we'll ignore that for now. When I dropped the ball from 15.5 centimeters, I only dropped it once. And that might be a little problematic, right? Because I don't know how good this data point is. I mean, let's say I go back and I do the experiment 2 more times. And at 15.5 centimeters, here are the 3 trials that I recorded. I got the exact same value every single time. That would be so great. Is my data that precise? I have no idea, just by looking at the single data point. Or maybe what happens is I go back and I do the trials again, and I get 8.7, but then I'm a little higher, and then I'm a little lower. This data fluctuates by plus or minus 0.1. Or maybe I go back and I do it again, and it fluctuates wildly. I get 9.7, 8.7, and 7.7. The data fluctuates by plus or minus a whole second. I can't look at this first data point and see which one of these scenarios applies. So it's hard to measure the fluctuation without repeating the trial 3 times. However, there is a way. Take a look at the graph. You see how there's this general trend that goes up as a straight line? Sometimes the data points lie above the line, sometimes they fall below the line. Here's what we could imagine doing. Imagine we went in and we measured how high is this data point above the trend line. And then we said how low is the next one below the trend line. And for every single data point, we measure how high up above the line it is or how far down below the line. And it's hard to draw all these arrows because some are so close, but I'm just going to add a few. Once we got those distances, we could say how much fluctuation is there on average from the trend. And that would be pretty similar to repeating our trials. Okay? That would be pretty similar. So how do we get Excel to calculate the distance from the line to the point? Well, here's what we do. First, we're going to find the line's y value. Like you see that first arrow that I drew? It originates at the line, at the trend line. So how do I find the starting point for that arrow? Well, if I take this equation, I can use it to calculate the line's y value. Here for x, I'm going to plug in the height, 15.5. Okay? So I do equals, I'm looking at my equation, I do 0.3855 times, and I click on the cell with my x value. And then I have to add the y-intercept, so again I'm looking at my graph, I'm looking at the equation. So I add 2.5636. So here's what I get, 8.5389. That is where the orange arrow starts. It starts on the line. This is the y value for the line itself. So now I want to know how much higher is my y value, my data point, how much higher up is it compared to the line? Well, I can look at these and say it's about 0.2 too high. That's why my arrow points up. So let me calculate that error. It's this minus this. I'm clicking the cells, I'm putting equals in the very first so that Excel knows to do a calculation, and I hit enter. Then I'm going to copy these, I'm going to highlight them both, click in the middle of the cell to highlight. I'm going to get the corner box, drag this down, and now Excel has calculated the y value for every data point, the y value on the line itself, and it's finding how much higher is this time, or how much lower is the time compared to the line. That's what this error is. So look at that second point. You see how the error is negative? That's because the arrow points down. My data point is below the line. How far down is it? Roughly 0.3. And that's seconds. These values, the line's y values, have units of seconds, and the error is time minus time, So it's in seconds as well. And why are they in seconds? Because that's what my y-axis is in. Okay. Now here's the problem. If I try to average these all together, you see how I get 0? That's because they should really mostly just average out. I mean, the whole point of a trend line is it's right in the middle of all the data. So if I want to average the distances, I shouldn't let positives and negatives cancel. So let me go into my equation. I'm going to type ABS for absolute value. I'm going to add parentheses. So now I'm calculating the absolute value of the error, which is just the distance from the point to the line. And I hit enter. And I'm going to copy that down. And now my average is more reasonable. Now this value right here is the average fluctuation from the line, right? It's the average fluctuation. It's your call what you want to use. Here's the biggest fluctuation. We could type, we could do the same kind of thing, but instead of the average, find the maximum fluctuation. Close parentheses. Which one you want to use, that's up to you. Oops, looks like my line shifted. But we have to use one of those values, right? Either the average or the max. We have to use one of them as our y error bars for this graph. Or if you have a curved line, you can actually bypass all of this and do STEYX, open parentheses. And then what you do is you don't have to calculate, you don't have to calculate either of these columns. We're actually just going to skip that. You could do STEYX, open parentheses, highlight your y values on the graph, my time, experimental y values, comma, you highlight the x values on your graph, and you close parentheses. And that's going to be somewhere in between the two. It's actually going to be, well, we won't get into it. So any of these three would be a suitable value to pick for your vertical error bars. Then, you go into the graph, we hit plus, error bars, we're going to delete the x error bars, delete the horizontal. We can double click on the y error bars, and then we click on fixed value. And which one am I going to choose? Maybe I'm going to choose this maximum, the biggest fluctuation. I hit enter. There it is. And now I have an estimate for my vertical error bars, my y uncertainty, or the y fluctuation, I should probably say. Okay? So this is how we can figure out what to put as our error bars when we did not repeat our data.